Okay, so let's take a look at the formula for margin of error again. So the formula for margin of error is E equals the critical value, right, times the standard error of the estimator. Okay, but what is this? What is the formula for the standard error of the estimator? It is sigma divided by the square root of n. Okay, now what I want you to focus on is where n is, where sample size is. Sample size is in the denominator. And the larger the sample size is, the smaller the margin of error. Okay? What that means is given a fixed critical value, which determines our confidence, right? This is our critical value comes from the confidence. We can keep the same level of confidence while decreasing the margin of error by simply increasing the sample size. Okay, so that means the higher the bigger the sample size, the better, the more accurate our estimate is. Okay, now of course in the real world, sample size, samples cost money, right? If you do any kind of research, you want to collect data. Every bit of data costs money. So it is important to know, right, before you conduct a study, how big of a sample size do you need to achieve a level to achieve a certain margin of error. Right? If I want to keep a margin of error below a certain amount, what's the sample size that I need? Okay. All right. So this is going to be based on algebra. We're going to use algebra to try to solve for that. So here is the formula. Right? Here's the formula. We're just going to do some algebraic manipulation. So here we go. Going to multiply by root n on both sides. We'll get root n times e, the margin of error, equals critical value times sigma. Okay. And then divided by e. So we get root n. Again, just algebra here. All right, we're just moving some variables around, divided by e. And then how to get rid of the square root? We square it. Square it. So we get n star. So this is the a sample size required. We can call it ideal sample size. And what is this equal to? It equals to critical value times sigma over e squared. So all squared. Okay, and that's the formula. And so once you determine, so we get critical value from what's the confidence level that we desire. Okay, so this is a choice. Sigma is going to be difficult, right? Because we don't know what sigma is, but we have to pick one, right? We have to assume one. And then margin of error, well, that's the margin of error that we desire, right? What's the maximum that we are allowed? Once you have these three, then this formula will give us the minimum sample size that we need. Okay, so let's give this a try here. So how large a sample do we need to provide a 95% confidence interval with a margin of error of 10, margin of error of 10, okay, assuming the population standard deviation is 40. All right, so we have a margin of error equals 10, right? 95% confidence interval, so alpha equals 0.05, okay, and then the standard deviation equals 40. So first thing I got to do is alpha equals 0.05. What is my critical value? So I can use my phone to get that. Okay, so just go to a normal distribution. I got a 0.025 because it's I'll take alpha divided by 2, do half. Make sure you go to greater than. Get that, so 1.96. Okay, now I have all that now. So let me go ahead and plug it in. So n star equals, here we go, 1.96 times sigma 40 all over 10 all squared. Okay, put that in. Okay, so put that in the calculator, you'll get 61.47. Now, with margin of error, right, we're talking about sample size. So clearly you can't have a sample size of 61 point something. So we need to round. Now, the rule with sample sizes, you always round up. Okay, so you have to say this means it's 62. If it's 61.05, you will still round up. to 62. Because if you round down, then your margin of error will be too high, right? So if I'm rounding up, then the margin of error, right, would be a little bit smaller than 10. If I round down, then I will actually run into the risk of increasing the margin of error. So this is the maximum margin of error that I'm willing to tolerate. Therefore, I have to round up. So that is the sample size. All right. Now, like I said, everything here is by choice except for sigma. Okay. Again, like how do we know? Well, first of all, we never know population standard deviation. First of all, and second of all, uh, second of all, right? This is done before the study, right? This is done before the study. Then we don't even have an estimate, right? We don't even have S to estimate this. So where does this come from? Where does this standard deviation come from usually? Well, there's a couple different ways, and this is not an exact science. Right? So here are this is kind of the procedures that your book listed. So we'll talk about it here. So sigma is unknown, right? It's not if, it's always unknown, right? Then we call this a preliminary, or we call it the planning value for sigma can be used. Okay, so there are basically three methods, right? And again, this is not there are maybe more, right? This is not an exact science. So one, we can use an estimate from a previous study. So if you're doing a similar study, let's say on income, then you can try to borrow the standard deviation estimated from a previous study. Okay. Two, you can use a pilot study. So just forget about sample size. Just collect a sample size of 10, right, of the population and get an estimate. So from this, you'll get an estimate S, right? Then use that as your estimate for the standard deviation. Okay. Number three, I like this one in the book. Just use best guess. Just use judgment. Guess a value for sigma. And I don't know how legit this. I don't know how legit this really is. All right. This is kind of questionable, but it is in your book, so I figure I'll just mention it here. There is another I found this technique in a different textbook that's quite nice. So one you know so one textbook offered this suggestion. You let your planning value, let's call the sigma hat. Right? This is your planning value. Let that be your range. Okay, so remember, range is just maximum minus minimum, right? Divided by divided by 4. So you will estimate, right? So you will first get a pilot study, but instead of not a pilot study. So you have a range. Excuse me. You have a range of income that you expect. Right. So for example, if I'm doing a study on income, right, then I know that I am looking at people that makes between $15,000 and $80,000, right? And so if that's the case, then I will take that range. So 15,000, so 80,000 minus 15,000, and then I'll divide that by 4. So in that example that I just made up, right, it'll be 80,000 minus 15,000. Okay, and then I'll divide that by 4, right? And let's see what we get. Okay, so I'll get 16,250. Okay, and so that will be my sigma that I will use for my study. Okay, that's one way. Again, this is tricky. Right? There's no exact science here because we're just we're grasping in the dark, right? We don't know what we have. Okay, let's try one more example here. Right? How large a sample should be selected to provide a 95% confidence interval with a margin of error of 3. So here I have to give an actual range. Well, let's use this one, right? Suppose that doesn't make sense. Let's do 80 and 15. Suppose I'm doing this in the thousands, so my range equals 80 minus 15, so that equals 80. Sorry about that. 80 minus 15, that equals 65. Okay. All right. So here we go. So again, I have my critical value. Now I had this already earlier, 95%. So 1.96. I got that above. Okay, my margin of error equals 3. So my planning value. So what's my planning value here? So that's going to be 65 divided by 4. So which should be 16.25. Let's just double check. Yes, right, 16.25. Okay, all right. Now I have all my pieces. Then now I can calculate what's the sample size that I need to make sure my margin of error is below 3. Okay, not around 3, but it have to be below 3. All right, here we go. Okay, plug that in. Okay, so we got 112.71. Right, now that means our actual answer is 113. And again, we always round up.